Right, my name is Dean Landry, and I'm here to present my project for STEC 503. The name of my project is Developing a Microcontroller Course Based Around the Arduino Uno for an Undergraduate Industrial Technology major. The purpose of this presentation is to support a prospectus developed on the subject to satisfy course requirements. The subject of the prospectus will also be used for my master's thesis in the future. This presentation is going to illustrate how other universities have implemented this type of course in their engineering majors, and it's also going to illustrate how this course would look in a technology major like industrial technology. Thesis statement: to outline the benefits of implementing a microcontroller course based around the Arduino Uno in the industrial technology major at the University of Louisiana at Lafayette. Microcontrollers and embedded systems. An embedded system is a computer system with a dedicated function within a larger mechanical or electrical system. Modern embedded systems are based around microcontrollers, which are just CPUs with peripheral interfaces. Microcontrollers are ubiquitous and are found in everything from digital watches to MP3 players to smartphones to kitchen appliances, millions of gadgets and appliances. What is the Arduino Uno? The Arduino Uno is a prototyping circuit board and platform based around the microcontroller unit known as the Atmega 328P, made by Atmel. Arduino is a company that builds the circuit boards based around the Atmel chips, along with incorporating all necessary electronics to create a device that's easy to use and connect to any computer. Arduino is the flagship prototyping board for Arduino, and is only one of many other products that Arduino produces. The cost for an Arduino Uno was anywhere from $5 from a clone or a knockoff company that uses the same exact chip and software to $30 if you buy it straight from Arduino. Because all information surrounding the Arduino is open source and free for anyone to use, many other companies came out with their own cheaper versions of the board. Arduino has developed its own programming language, which is a modified version of C++, known as Arduino Design Environment, ADE. ADE uses portions of C++ that's needed just for microcontrollers, which greatly simplifies the language and offers a shallow learning curve for novice programmers. This is a picture of a sketch for the first project that most Arduino users will encounter. That's analogous of the Hello World program that most computer programmers begin with. What the Arduino is used for? It's used for developing interactive objects. It's used for taking input data from sensors and controlling outputs. It's used for prototyping, and it's used for communicating with other devices. Literature review. This prospectus is based off of a research paper that was produced by Nathaniel Bird, who was an assistant professor of computer science at Ohio Northern University. The title of his research was Use of the Arduino Platform for a Junior Level Undergraduate Microprocessors course. The course was specifically designed for electrical engineers and computer engineering students. My course objectives. It's going to be my goal to develop a course plan that closely resembles the course implemented at Ohio Northern University, but with the following changes. Instead of designing a course for engineers, it's going to be designed for technology majors. I'm going to correct some of the problems that were found with the course and were documented in the research paper by Nathaniel Bird. And I'm going to use the course to act as an extension of existing iTech electronic classes like 424 and 329, 322, courses like that. The course layout for Nathaniel Bird's research paper. His course included a midterm and a final. His course had weekly directed laboratory assignments as well as a semester-long project. He had 3 written reports that were required and used as communication about the final project status. And they were due throughout the semester, 3 times throughout the semester. He also required a live PowerPoint presentation of the final project, demonstration video on YouTube, and he also required a student survey at the end of the semester just to get feedback on what the students thought about the course. And it ended up being successful, so successful that they ended up using the Arduino permanently for that microprocessors course. The course did have some problems though. The required textbook was found to be less than useful. At the time, it was because at the time there was limited published information on Arduino products. That was back in 2010. 2013, there are a lot more published textbooks and books. Another problem was there was no universal component kits used in the course. So basically what he did, he gave his students a shopping list of items and components to go out and buy. And it caused problems because the students came back with different components than other students. Continuity issues. Students came with components later on in the semester, while some students came on early in the semester. Just ran into a host of problems with it. So to alleviate those 2 problems, I chose 2 books. The first book is made by a man named Jeremy Blum, who's a graduate of Cornell University in electrical engineering. It's called Exploring Arduino. It's got a lot of projects in it. It also has a lot of engineering theory backed with each project. It explains electrical engineering theory behind each project. Another good book is made by Make, Getting Started with the Arduino, the open source electronics prototyping platform. And it's made by Massimo Banzi, who is one of the co-founders of Arduino. Good book. And for the other problem, there are a whole host of electrical component kits for the Arduino and for other electronic controllers, microcontrollers, all over the thousands of kits, ranging anywhere from $5 to $60. So either choosing one of these kits and making it a requirement of the course, or picking and choosing based off of the labs that were set up by Ohio Northern University. Get the components that they were using and make sure that all the students have the same components. But in closing, I think this is going to be a good course for the students. I've been getting a lot of positive feedback in 424 about another electronics course based on microcontrollers, and I really think it would help tie together all the electronics based courses in the program. And added bonus, it would help to introduce students to higher level programming like C++.